Okay, so it says the question says something like this. There is a inclination, very small one, just 5 degree, and first the car is, let's say, at this position. Let's call this position at position A, and then this one comes down, slides down. The engine is stopped, but it's slides down because of the inclination at point B. So the velocity at point A, if we say VA, that is 30 kilometer per hour, and velocity at point B is 40 kilometer per hour, and this surface is with friction. So there is also this distance is given, which is 50 meter. So we need to find what is the change in the mechanical energy from point A to point B due to the frictional force. So if there was no frictional force, the mechanical energy wouldn't be changed. That is, the sum of the kinetic energy and sum of potential energy would be the same. Only the potential energy here would be converted into kinetic energy. But because of friction, that's not the case. So let's first see what is the total mechanical energy at point A. That would be kinetic energy at, kinetic energy at point A plus potential energy at point A. So that will be half m VA square plus mg. We need to find this height d, height h, let's call this h. That will be, of course, this distance is d here, 50 meters. So the height will be the angle we know, which is 5 degree. Height will be d sine 5 degree. D sine theta, theta is 5 degrees. So that's VA. So that's the potential total mechanical energy at A. We can call it MEA. And then this potential energy, this one is relative to point B. So at point B the potential energy will be 0 because it depends on the height difference, and we are assuming that here the point A's potential energy is this much with respect to point A's potential energy. So point A's potential energy will be point B's potential energy will be 0 because it has come down up that much height. It has covered that height. So mechanical energy at mechanical energy at B will be kinetic energy at B plus potential energy at B. That will be half m VB square plus this will be 0. So now if we want to the frictional for energy will be, we can call it, I don't know, UF maybe, frictional energy. That will be mechanical energy at point A minus mechanical energy at point B. So our here it will be half mVA square plus mg d sine theta, sine 5 degree, I will just write 5 degree, minus half mVB square. So half is there, and then 1500. The velocity is given in kilometer per hour. We need to convert that into meter per second, so that will be multiplied by 1000 divided by 60 times 60, that is 3000. So that is basically multiplied by 1000 divided by 3600, that is dividing by 3.6. so that I will write that directly, divided by 3.6 square plus 1500 times 9.8, 50 sine 5 degree. I have run out of space. I will continue in the next page. Half into 1500. So now I am writing this part, half mv b square. That will be again 40 divided by 3.6 because that velocity is 40 kilometer per hour. So converted to meter per second, like that. So I will just write the result directly. What I got exactly is 23.55 kilojoule. Did I write that? Yes, 23.55 kilojoules. That is the result I got. And then, and the second part, it says that what is the magnitude of net frictional force. So of course net frictional force magnitude will be UF, will be frictional force, if that is FF, times the distance that it has traveled, so that's D. So FF will be of course just UF over D. So once I do the division, what I got is 471 Newton. So that's the force. So basically UF, which is this one, 23.55 kilojoule, and when it's multiplied by what is divided by 50 Newton, 50 meter, I got 471 Newton. That's because I will just write that properly. So 23,550 in terms of joule, because this is 23.55 kilojoules, that divided by 50, that gives me 471 Newton force, the frictional force.